I took up a lot of space to do this, but I want you to try one on your own. So why don't you guys try this B on your own? Because I think this integrating the absolute value thing is the hardest thing we're going to do in this section. So let's just knock it out early. Okay. So you want to find the net displacement. And then you also want to find the total distance traveled. So try that. I guess you guys get 2/3 for the net displacement. Is that what you guys got? All right. Cool. The total distance traveled is a little bit harder. The first thing we need to do is we need to set the velocity equal to 0. So that's going to give you 0 is equal to t squared minus 2t minus 3. And you need to factor that. So that's going to give you a t minus 3, t plus 1. And in this case, this gives you that t is equal to -1 and 3. Now, if you look, our time is only going from 2 to 4. So I feel like you should set this up where you're integrating one piece of the absolute value of v of t from 2 to 3, and then the next piece from 3 to 4. Okay. Jason, are you still working on this one?
I think I'm almost done.
Okay. I want to give everybody a little bit of time to break this down. Question?
Yeah, why do we choose from 3 to 2, not from 2 to 0?
Do you see the part I highlighted here?
Yeah.
We're starting at time t equal to 2, not t equal to 0.
So for number 3, for 3 is just a random number between 2 and 4.
This 3 here?
Yes.
No, that's where the velocity is 0.
Oh, okay. Thank you.
Mhm. Apple TV. All right. So let's try to break this thing down. I know that I want to split my function into two pieces. And I want to identify which piece is the positive piece and which piece is the negative piece. Now, there's many ways that you could figure this out. And I guess I'll describe a couple of the ways. The way that I think about it, I'm a very visual person, I guess. So I would take a look at this polynomial, this thing right here. And can we all see that this is a transformed parabola? Because of the t squared, it's a parabola. My question for you is, do you think it opens upwards like this, or do you think it opens downwards like this? What are your thoughts? Up or down? Anyone? Joe says up. I'm inclined to agree. Joseph, what tells you that it opens upwards? How can you tell when you look at this that it opens upwards? Because you're correct. He looks at the coefficient in front of t squared and it's positive. So if I were to try to draw a graph of this guy, I know the graph is going to open upwards. I also know that it's going to cross at t equal to -1 and t equal to 3. So I could really come over here. Here's -1, here's 3. I think that the function looks something like this. Does that make sense to everybody? Because how else could a parabola look where it's opening upwards and it crosses at these 2 points? Now my region of integration is going from 2 to 4. But just by looking at this picture, I can see where the graph is negative and where the graph is positive. In other words, it's negative on this part right here, because that's below the x-axis, and it's positive on this part right here, because that's above the x-axis, right? So if I were to go to write my absolute value function, my absolute value function looks like this. The absolute value of v of t is going to be negative t squared minus 2t minus 3 if t is between, in our case, we only care about it being between 2 and 3. So we're going to go from 2 to 3 like this. And it's going to be positive, so we'll just leave it alone on the parts that are bigger than 3. So this will go from 3 to 4. I could write more detail, but because I only care about the region from 2 to 4, I'm only going to write these pieces. Does that make sense to you all? Is there any questions? So I guess if I were to write it down, I can say that now I'm just going to integrate from 2 to 3. This is going to be negative t squared plus 2t plus 3 dt. And then the second piece goes from 3 to 4, and that's just my original function, which is t squared minus 2t minus 3 dt. Then we just got to integrate each piece. So this becomes negative t cubed over 3. This becomes plus t squared. This is plus 3t. And we're going to go from 2 to 3. This piece is t cubed over 3. This is minus t squared. And this is minus 3t. And we're going to go from 3 to 4. So now you just plug in the numbers. You're going to get 3 squared is 27. 27 divided by 3 is 9. So it'll be minus 9 plus 9 plus 9. That's what you get when you plug in the 3. Minus, you're going to get negative 8 over 3 plus 4 plus 6. And that's just the very first integral. For the second integral, we're going to get 4 cubed over 3 minus 16 minus 12. And then we're going to get minus, that's going to be 9 again. That's going to be 9 again. And this last one is going to be 9 again. All right. And then I'll let you simplify that at home. But that's going to be how we get our answer. This is probably that Chinese lady that calls me all the time. I'm just joking. I get a lot of junk calls. Any questions? So I think this is the part that you're going to have difficulty with. I think everything else is pretty straightforward.
I have a question.
Yes.
For if you scroll up, to get that interval 2 is less than or equal to t less than equal to 3.
Mhm.
How do you get that?
Did you understand this picture?
Not really.
Do you understand that this is a parabola?
Yeah.
Do you understand that it opens upwards?
Yeah.
Do you understand that the intersection points are -1 and 3? So I know my parabola is going to have to pass through these 2 points, and it has to be a parabola that opens upwards. So it has to look something like that. Does that make sense or not really? Right? The graph crosses the x-axis where it's 0.
Yeah.
And then it opens upwards, so I can't draw it going downwards. It has to open upwards like this. And then when I look at this picture, the region I care about is from 2 to 4, because that's my region of integration. But I can see that it's below the x-axis from 2 to 3, and it's above the x-axis from 3 to 4. So that's why I split it from 2 to 3 and from 3 to 4. Does that help or not really?
Yeah, that helps. Like that little section from 2 to 3 is
Right.
negative.
Let's say you want to do this without graphing it. So this is how I think about things, because I'm always trying to imagine what things look like. But you didn't have to do it this way. What you could have done is you could have done it like this. So let me just copy this part down here. So let's say you don't have, you suck at drawing pictures, it gives you anxiety, you're like, I don't want to do that. That's fine. What I can do is I can use a number line. The part I care about is from 2 to 4. 3 is in the middle. And I know that that's our splitting point, right? So what you can do is you can just try a test point. You could take what's V of 2.5. And if we check, V of 2.5 is less than 0. So it's negative on this part. What's V of 3.5? If you plug 3.5 into the velocity, you're gonna get a number bigger than 0. So that part's positive. So that would be another way that you would know that when you want to write down the absolute value of V of t, it's going to be negative the original function for the x values from 2 to 3. And it's going to be the original function t squared minus 2t minus 3 from 3 to 4. This way it doesn't involve graphing at all. It involves using test points. Use test points to see where v of t is less than 0.